No, we need to go to a more urban area. That way there's a greater population and there are more suspects. That way we have a less likely chance of getting caught.
No, you're stupid. We should save the country. Nobody even knows who we are. You and your stupid captain.
Here's what I think of you.
Fuck you. I am right.
No, I am right.
I am right.
Urban is better.
Country is better.
Urban is better.
Oh, but just us again.
I think it's better that we commit crimes in urban areas.
What do you think?
I don't know how we're supposed to know that.
We can use the chi-square test.
Oh, I knew something Holloway taught us would come in handy one day.
Meet us in the KTH basement later, but leave that cap gun at home.
Let's go. We gotta come in some fun.
Now there was a time when
Oh, hey guys. You ready to learn about SPSS?
Let's do it.
We're going to use the 2009 census. Let's go. The chi-square test is one of the most frequently used hypothesis testing methods in social sciences, due to the fact that the assumptions and requirements in step 1 of the 5-step model are easy to satisfy. The test can be conducted with variable measured at any level of measurement, since it is non-parametric or distribution-free test. It requires no assumptions about the shape of the population or sampling distribution.
Chi-square is calculated from bivariate tables, which display the scores of cases on two different variables at the same time. Bivariate tables are used to determine if there's a significant relationship between the variables. They consist of two dimensions, rows and columns. Each column or row represents a score on a variable, and the intersections of the row and columns or cells represents the various combined scores on both variables.
For our example, the chi-square test will be used to test the independence. In this case, independence is defined that two variables will be independent if the classification of a case into a particular category of one variable has no effect on the probability that the case will fall into any particular category of the second variable. The null hypothesis for chi-square is that the variables are independent.
Though useful in this context, we must remember the limitations of the chi-square test. Though it is flexible and can handle a variety of variables, it becomes difficult to interpret when the variables have numerous categories. As a general rule of thumb, the chi-square test is easiest to interpret and understand when both variables have 4 or fewer scores.
Two other limitations of the test relate to sample size. When sample size is small, it cannot be assumed that the sampling distribution of all possible sample outcomes is accurately described by the chi-squared distribution. For chi-square, a small sample is defined as one where a high percentage of the cells have expected frequencies of 5 or less. The rule of thumb is to take corrective action whenever any of the cells have expected frequencies of 5 or less. We must apply Yates correction for continuity, which we will see later.
The other limitation relates to a large sample sizes. The probability of rejecting the null hypothesis increases as the number of cases increases. Chi-square is especially sensitive to sample size, and larger sample sizes may lead to the decision to reject the null when the actual relationship is trivial.
Our SPSS example will examine if criminal victimizations varies by area or residence. We will ask 2 questions. Is area or residence significantly related to criminal victimization? And if so, are persons residing in an urban or rural areas more likely to be a victim of crime?
To begin, use the 2009 GSS data. From the main menu bar, click Analyze, Descriptive Statistics, and then Crosstabs. Crosstabs procedure in SPSS allows us to produce bivariate tables along a wide variety of statistics. The Crosstabs dialog box will appear with the variables listed in a box on the left. Highlight Ever Been a Victim of a Crime, Lifetime, and click the arrow to move the variable name into the Rows box. Then highlight Urban-Rural indicator and move it into the Columns box. Click the Statistics button at the top of the window and click the box next to chi-square and then click Continue. Next, click the Cells button and check the boxes next to Expected in the Counts box and Column in the Percentages box. This will produce the expected frequencies and column percentages for the table. Click Continue and OK, and the output will be produced.
As seen, each cell displays the observed frequency, or the number of cases in the cell that says count. The column percentage that cell is percentage within urban rural. There were 787 respondents, or 65%, who lived in an urban area that had answered yes to being a victim of crime, whereas there was 157 respondents residing in the rural areas, or 52.2%, who reported being a victim. Therefore, people who live in urban areas are generally more likely than those in rural areas to have been a victim of crime at some point. The table also displays the expected frequency for each cell. The greater the difference between expected frequencies, expected count, and observed frequencies, count, the less likely that the variables are independent and the more likely that we will be able to reject the null hypothesis.
The value of the obtained chi-square is found in the row Pearson chi-square. The value of the obtained chi-square is 16.915, the degree of freedom is 1, and the exact significance of the chi-square is 0.000. To test if there is a significant relationship between the variables, we can manually compare the value of the obtained chi-square to the values of the critical chi-square, determined by consulting the chi-square table in Appendix C for a particular alpha level and degrees of freedom. But SPSS provides the exact probability so that there's no need to look up the test statistic in the chi-square table. The exact probability value is 0.000, is well below the standard indicator of a significant result, where alpha equals 0.05. Therefore, we reject the null hypothesis that the variables are independent and conclude that there is a statistically significant relationship between area of residence and victimization.
Being a victim of crime is dependent on the area of residence, and those living in an urban area are more likely to be a victim. The number of cells with expected frequencies less than 5 is provided at the bottom of the chi-squared test output box. Yates correction for continuity, labeled continuity correction, should be used in a 2x2 table where one or more cells have expected counts less than 5.
See, I told you it was urban.
Okay, let's commit some crimes.
Django, have you always been alone? Django, have you